Hi there, Turgeon here, bringing you physics from afar. Very much regret that I can't be there today. And I want to give you a sense of what needs to happen so we don't lose more time on this lab report. So whenever the teacher's out, always check the stream, always check your email, and always check classwork, especially things that are due before the next class. And you should assume things are going to be graded, and you should assume there's going to be something that needs to be done that day. So for today, your goal is to get something into the data table and then to get some progress done on your lab. So you want to work together. And then as you've done a very good job all year, make sure you're also doing your own work. So you're working together, but you're making sure you're putting things in your own words and stuff. The data table, you may not know how to get the percentage, but I think some people in the class do know how to get their percent correct. So get your values into that data table. I believe it was laying down on the surface, so we could get that hooked onto those metal hooks so that it's there for all to see, because that's the class data table and everyone's going to use that. And then you'll be able to see the results essentially with regard to our purpose on this entire lab experiment. But procedure and diagram, you can do that now. You can draw the picture. You can start laying out the steps. Again, make sure these are different from your group. I want to see that people thought about this individually, and I don't want everybody to have the same procedure. As crazy as that sounds, people are going to have very different ways of explaining what to do that are still correct. Some key things, obviously, like making sure you're zeroing the force sensor, all these little tricks about using that sensor, such as what's the deal with the string, showing evidence that you really understand what was going on. The diagram can be drawn on paper neatly, and then you could take a picture and insert it into the Google Doc. That's what most people like to do. Your graph is going to be a graph of the two elements of Newton's second law that we are testing the relationship. Graphs show relationships. Graphs are models. A relationship is a model. Graph is a particular representation of that. Graphs show relationships. Newton's second law is a relationship. We didn't test the relationship related to mass. So this is a graph of force and acceleration. So we want to see if there is the relationship we predicted. So you're always going to make a scatter plot. You're making it yourself, even if your graph is going to end up looking like your group's. I still want to know that people know how to make their own graph. Which means you have to think about the scale, always label the scale, always give it a meaningful title. A scatter plot means you're plotting points. Don't connect the points. We'll talk about that later. In your conclusion and discussion, which you can start this weekend, and I may make a classwork assignment where I want to see some progress on that. So in your conclusion, you always go back to the original purpose. You always think about what we were trying to do, and then you can make a statement. Be assertive. Say, this is what I conclude about what the data says the results were. A very interesting conversation yesterday about theoretical versus experimental, and people saying, well, we can get the mass because we can calculate it, or we can get the acceleration because we can calculate it. However, all you're doing there is you are just using the equation. You're not proving the equation. You're showing what should happen, what the theoretical value of the acceleration or the theoretical value of the mass or the force. We need to measure all three. So the thing to write down here is measure all three. So this also goes back to the introduction. This is why people kept asking, and I totally understand this. I totally get this. People kept asking, where do I write that? Honestly, a lot of the things we talked about will appear in your introduction and your procedure and your discussion, so that it all connects. For example, this idea of relationships, that relationship is occurring in your graph, it's occurring in your data table, it's discussed in your introduction, It's maybe even discussed in your procedure. It's definitely discussed in your discussion. So we'll talk more about discussion, so don't worry too much about that. If I do have an assignment related to that, it's just going to be to make progress on things I've said. And by the way, this is a video, so rewind and listen to some of this stuff again. I just want to get you going for the day, and I want you to take this day seriously. I'll take care of you. So I understand the limitations that you're under because I was out so much this week. And I'm the one doing the evaluation. I'm the one seeing how hard you're working. So don't worry. Listen to this video if you need to multiple times. Make as much progress as you can. If you're not sure of something, just do your best guess and just ask for feedback next time we meet. This has been Turgeon bringing you Physics from Afar.